No.
It's the amount of matter, the amount of stuff something has. They have almost exactly the same mass. So they represent a unit we call atomic mass. Electrons, they're incredibly small. A proton is more than 1,800 times bigger than an electron. So you can just leave them out. So electrons, they don't matter. Okay, now we know sufficient knowledge of chemistry, at least I think. So we can go on to the more cosmological, this is so hard to say, astronomical issues. Oh, my hydrogen atoms! So inside Bill's core here, so let's say we have a screen here that shows what's happening inside the core. Now, hydrogen atoms start to slam into themselves and make helium. And this is incredibly complicated. Now, hydrogen can come together and create a heavier isotope of hydrogen. An isotope is something that is a type of hydrogen, usually with more neutrons or less. This time, not with just one proton and one electron, but one proton, one neutron, and one electron. At least I think so. This is incredibly complicated, okay? So two of these hydrogen, now we call this isotope of hydrogen, one proton and one neutron, hydrogen 2. Now hydrogen 2 atoms, I'll just write H2 here. Can come together with another hydrogen 2 here to make helium 4. Now the 2 here is the number of nucleons, the 1 here is the number of protons. And remember, this is not in exact detail, it's incredibly complicated. This is just an oversimplification. I think so. So we have this formula here in which nuclear fusion can make a lot of energy. When temperatures are just right and pressures are just right, two hydrogen atoms can slam together, overpowering the electromagnetic force, and they create a helium atom. In that process, a tiny amount of energy is released. A tiny amount of the atoms break apart and become energy. Now, when I say tiny, you think that a little bit of energy is being released. Wrong. There is a lot of energy released during that process. It could power the world. No. It could power this whole city. If we have one nuclear reactor that uses nuclear fusion, then the whole city could be powered for a very long time. At least that's my estimate. Okay, so Bill here, if he's doing this nuclear fusion in his core, then he has become a main sequence. a main sequence star. Oh, what star? Now during this period, now this is the period in which stars spend most of their lifetime just being like this. It's the stage of life in which our sun is in. And now for the questions. Okay. Now, how does a star start its life?
The supernova.
No!
No?
That's the end!
Ah.
This is the end! This is the end! Thẳng lưng.
Yes.
So,
First is a nebula.
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 Or plural, nebulae. I think so. And what stage comes next?
Protostar.
Yes, the protostar stage, in which hydrogen starts to clump together and the protostar gets warmer and warmer. And then what is the main life stage in a star?
This is main sequence star.
Yes, a main sequence star. Oh, the warm star. We're so lucky it's not in a giant stage. Not for the next 5 billion years at least. And what is the defining characteristic of an element?